Hi everyone, my name is Kayla Cervera and I'm a project engineer here at Risk Management Professionals. Today I will be continuing our ongoing Nevada CAPP webinar series with a presentation on the Standard Operating Procedures or SOPs program. The focus of my webinar today will be on how to successfully implement the Nevada Department of Environmental Protection's regulations and also how to utilize their checklists that are used for guidance during compliance audits and inspections. I will also provide helpful tips on how to organize your SOPs using an operating limits table that shows regulatory compliance while providing operators with an easy-to-navigate troubleshooting table. Here's a little background of RMP. We provide a multitude of services for your process safety management and risk management program needs, including process hazard analyses and compliance audits. We have worked extensively with specific local and state regulations related to chemical release prevention programs, including CalARP in California, and of course, CAPP in Nevada. On today's agenda, we are going to take a look at the regulatory history of Nevada's Department of Environmental Protection, or NDEP, and some of the regulated chemicals that drive applicability, the NDEP guidance provided to ensure compliance, and then we'll dive into the specifics of the SOP program. This will include the types of operations that need to be included in SOPs and how to incorporate the system's operating limits. The last couple points will be requirements less commonly known to regulated facilities, such as safety and health considerations, safety systems and their functions, the overlap of process safety information, or PSI, and safe work practices. We'll then conclude with a summary of the webinar. The NDEP website provides information regarding regulated chemicals and threshold quantities that determine applicability of the Nevada CAPP program. Below is a list of chemicals of interest that facilities are commonly regulated for. CAPP considers two types of threshold quantities, one for the total inventory contained on site, the other, which is referred to as CAPP2 release, is for the quantity of two or more releases of regulated chemicals that have occurred at the facility during a 12-month period. Your facility may be applicable to CAPP due to meeting the CAPP2 release thresholds, even though it does not meet the other CAPP threshold. This slide displays all the program elements of the Nevada CAPP program. In comparison to the EPA's Risk Management Plan and OSHA's Process Safety Management, most of the program elements are redundant. In most cases, this allows regulated facilities to comply with all three regulatory agencies with one program. Today, we will be focusing on SOPs. All of today's topics are based off two NDEP provided documents regarding the SOP program and are available at the link provided on the slide. The Element Audit Checklist is used by NDEP for facility audits and can also be used to perform the triennial internal compliance audit required by Nevada CAPP. The data form provides additional details regarding all the requirements listed on the checklist items. In the case of the SOP program, it provides facilities help in identifying what operations warrant inclusion in their SOP and what type of additional details must be included. SOPs are generally created based on the entire unit or process where the regulated chemical is used. There may be multiple types of operating modes depending on the size and intricacy of the process. Some common ones listed here are startup, either after maintenance or a turnaround, or after an emergency shutdown, or ESD, normal operations, and shutdowns, both emergency and normal. Generally, these will always be included in the SOPs. There are some operations that are not typically utilized. However, your system should be thoroughly examined if these needed to be included in your SOP. Initial startup and commissioning procedures are warranted when this is the first startup of this process or the piece of equipment. A hint to whether or not this may be applicable is whether there are additional cleaning, purging, or flushing that is required per your provided operations manual or as dictated by the equipment manufacturer prior to startup. The procedures for these steps may be minuscule and might only be used once, but these must be included in your SOP. The next type of operation to be looked at is standby mode. This is more commonly utilized as systems are becoming more automated, such as there is the ability to temporarily stop operations in a safe manner to make process changes. A procedure for putting the system into standby mode should be developed in a manner that allows a restart in the near future. The system should also be examined to determine whether or not there is a need for instrumentation readings or valve positions to be verified prior to pressing restart via an HMI or other type of control panel. Lastly, temporary operations and emergency operations. Typically, temporary operations include draining or filling during normal operations. The system should be analyzed to determine what type of mode the system should be in prior to starting a temporary operation, such as standby or complete shutdown, and what steps are required prior to returning it to normal operations. Emergency operations aren't typically utilized as the system usually remains shut down until repairs are made. However, if the system is designed to operate with the loss of a piece of equipment, this will need to be examined for inclusion in the SOP. A likely example of emergency operations would be the loss of power and switching over to a backup power source. Operating limits are required to be included in each SOP. This includes all process parameters, typical ones being pressure and temperature. Some that may not be typically thought of are valve positions and lineup. The system's process safety information, or PSI, should be referenced to identify safe operating limits associated with equipment and piping. The set points of most instrumentation and safety systems are associated with upper and lower safe limits of operation. Consequences of deviation from this limit and steps required to correct or diagnose should also be included. This provides operators with troubleshooting steps to safely determine the reason for the system operating outside normal ranges. The system's PHA is a great resource to identify the hazardous consequences associated with these deviations. In that sense, the creation of an operating limits table proves to be efficient, in which it's easy to identify the parameter and set points of equipment that may be out of operating range, and it helps with regulatory compliance by addressing most NDEP checklist items. This slide is an example of an operating limits table with a deviation that will cause an inability to start up. I'm going to quickly read through it, and then I'm going to go into detail in the next slide. So we have a couple of columns here. The first one is our phase of operation. So in this case, it's initial startup. We have our actions and checks. So this is what the intentions of this check is and what they are trying to verify. We then have our set point, which is 100 pSig. So anything below that, as read by our pressure transmitter 01 on our air supply, will result in an inability to operate air actuated valves and the diaphragm pump. So as a result, the system will take some automated action, which will be to alarm at the HMI and will also keep the system from starting. As a result, the operator's action will then be to verify the block valve on the air supply, HV01, and make sure it's in the open position. They'll also need to verify the reading on the local gauge, PG01, to determine whether or not PT is reading incorrectly. And then they will attempt to restart/start the system via the HMI. So here, I've identified a couple items from the NDEP SOP checklist that I mentioned previously that this particular operating limits table will satisfy. First, I've identified which operating mode or phase where this operating limit is examined. In this case, it's at initial startup. This will help the operator easily navigate through the table to the appropriate phase in which he's identifying the problem. Point 1 is satisfied by identifying the safe operating limits for pressure in this case. Point 2 identifies what would happen if there's a deviation from this set point. Point 3 is met by defining what the system's action would entail without an operator and also the additional steps that the operator must take to diagnose the problem and attempt to bring the system back into normal operation. Lastly, point 4 is the consistency with PSI. This is met by utilizing accurate tag numbers, set points, and resulting actions that will match those documented in the system's PSI. This slide is very similar to the last operating limits table. However, deviation from this particular set point will require a manual ESD. I'll quickly read over it again. So first we have our phase of operation, which we are in normal operations. We have our actions and checks. We have our set point at 10%. So if we are above 10% of the LEL, as read by our equipment tag, LEL01, we have the potential for an explosive atmosphere within the process area. So again, the automated action of the system is to alarm at the HMI, and it's also going to put some audible alarms in the process area. So this actually entails some operator action. So the operator must initiate ESD using HMI or available ESD buttons. So in this case, ESD 1 and 2, evacuate the area, and then follow emergency action procedures. Here, points 2 through 5 are similar to the last example. Point 1, however, is a specific requirement outlined in the NDEP SOP checklist, where conditions under which an ESD must be initiated manually and where there are operator responsibilities, it must be clearly identified. This is what's been accomplished by adding this operating limit as such. If the LEL01 acted as a trip of the system when reaching above the set point and put the system into an automated ESD, this is also required to be documented in the tables. Health and safety considerations must be included in the SOP. I've outlined the main points of these items, which include the primary hazards and characteristics of the chemical. An example I like to use is for propane. As it's a flammable chemical, all potential ignition sources should be eliminated, and it tends to sink due to its density. Required PPE, administrative controls, and engineering controls should be documented. Again, for propane, anti-static clothing should be utilized to avoid potential ignition sources. Control measures are documented typically in the facility's emergency action and or response plan and in the safety data sheet, SDS. The location of these items may be helpful to include. All of this information just discussed can be found in one place, the chemicals SDS. This would be the best source of information for H&S considerations. Quality control for raw materials. This is based on the facility. Usually, if raw materials are being handled and loaded, there is an SOP particular to that operation. Control of hazardous chemical inventory levels should be covered in the facility's storage procedures and should designate an appropriate storage location. And lastly, document the unique hazards that chemicals may present, like propane in a liquid state can cause frostbite upon exposure. A list of all safety systems should be included in the SOP. There are some examples listed in this slide. These can also be included in the operating limits tables to include the transmitters and associated set points. It is most important to identify the action of these safeguards, whether it's an ESD or if it triggers an audible alarm. The biggest concern in regards to PSI is ensuring that the information provided in SOPs is accurate and consistent with PNIDs and other PSI documentation. This is looked at across all Nevada CAPP program elements and warrants a review against PSI during development of any documentation, including SOPs. Applicable safe work practices, or SWPs, should be referenced in the procedures to allow operators to utilize them as needed. Some common SWPs are listed in this slide. The NDEP SOP checklist also includes specific requirements met for some SWPs, such as hot work, which requires that fire prevention and protection requirements be implemented prior to work per 29 CFR. It should also be specified in the SOP that any work in the procedure should be assessed if not already identified and the applicable SWP be implemented. The need for additional SWPs should also be assessed while creating SOPs to ensure that all procedures are performed safely. In conclusion, the NDEP has provided very helpful guidance documentation for the creation of your facility's SOPs. It includes these major points to keep in mind. Evaluate your system for all types of operation, even those rarely used. Create an operating limits table, an organized and easy to read way of examining all potential deviations and associated safety functions. Refer to your chemicals SDS and compare PSI against your SOP. And lastly, additional procedures without sufficient safety systems might require the development of a safe work practice or SWP. Thanks for joining today's webinar. If you have any questions or would like more information about RMP, feel free to reach out. Again, my name is Kayla, and you can find all my contact information below.